If somebody gives you an unknown molecular compound, then you don't know the molecular formula of this compound, or its condensed structural formula. But you may be able to figure out the mass percentages of the elements in the compound. And if you can do that, you can determine the so-called empirical formula. The empirical formula is the most simple representation of the molecular compound, as it expresses the relative number of atoms in the compound. What the empirical formula does not show, therefore, is the actual structure, or the actual number of atoms in the compound. It only expresses the relative amount of atoms in the compound. So how do you get these mass percentages? Well, they must come from experiment. Experiments like atomic absorption spectroscopy, mass spectroscopy, or gravimetric analysis will give you mass percentages from which you can determine the empirical formula. Let's give this a try. Let's say I have a white pigment, and elemental analysis shows that this pigment contains titanium and oxygen elements. It also tells me that 59.9% is titanium. Now, these two pieces of information is enough to determine the empirical formula of this compound. How does it work? The first assumption I'm making here is that I have 100 grams of this compound. And if I have 100 grams, I know that 59.9% of that is titanium, which means 59.9 grams of titanium in 100 grams of the compound. That also means that 100 grams minus 59.9 is the amount of oxygen, which is 40.1. 40.1 grams of oxygen. The next step I like to take is to convert these amounts in grams into moles. So I take 59.9 grams of titanium divided by the molar mass of titanium, which is 47.8 grams per mole. And I find 1.25 moles of titanium. I do the same for oxygen. 40.1 grams of oxygen divided by the molar mass of oxygen, which is 16 grams per mole, is a total of 2.51 moles of oxygen. So I have the amount of moles of titanium, the amount of moles of oxygen in 100 grams of the compound. Now the ratio between the two is 1.25 divided by 2.51 equals approximately 2, or 1 over 2. So for each one titanium atom, I have 2 oxygen atoms, which means that the empirical formula is titanium 1, oxygen 2. Combustion analysis is a useful way to determine the empirical formula of hydrocarbons. Hydrocarbons are compounds that contain C and H, for instance, CX and HY. X and Y are the parameters I need to determine the empirical formula. In doing so, I let it react with oxygen to produce, in a combustion reaction, CO2 and H2O, carbon dioxide and water. Now, the number of carbon dioxide molecules is determined by how many carbon atoms I had initially. It is X. If there were X moles of carbon atoms, I can produce X carbon dioxide molecules. The same is true for water. You see that water contains 2 hydrogen atoms. These hydrogen atoms must have come from the Y mole of hydrogen atoms in the hydrocarbon. That means I form half Y moles of water molecules, because each water contains 2 hydrogens. The reaction works as follows. I have a reaction vessel, and I have my unknown compound in there. I let it react with oxygen. And in doing so, I produce CO2, H2O, and the remaining unreacted oxygen. Now, the number of CO2 molecules is related to how many moles of carbon I had initially. And the number of moles of water molecules is related to the number of moles of hydrogen atoms that I had initially in my hydrocarbon compound. So, in other words, combustion analysis is a way to determine the empirical formula by looking at the amounts of CO2 and H2O produced. Let's look at the following example. In this reaction, I produce CO2 and H2O. This is a combustion reaction. This hydrocarbon produces a total of 3.38 grams of CO2 and 0.69 grams of water. Now, using these amounts, I can determine the amount of carbons and the amount of hydrogens, which allows me to determine the empirical formula of the hydrocarbon. First, let's look at the number of carbon atoms. The number of carbon atoms is proportional to the number of CO2 molecules that I produce. I produced 3.38 grams of CO2. How many moles is that? Well, you divide that by the molar mass of CO2. And I find a total of 0.0768 moles of CO2. That means 0.0768 moles of carbon. How many moles of hydrogen do I have? Well, the amount of hydrogen in my original compound is twice the amount of water molecules that I form, because each water molecule has 2 hydrogens in it. That means 0.69 grams of water divided by the molar mass of water is the amount of moles of water, but each water contains 2 hydrogens, which means I multiply that by 2. I find a total of 0.076 moles of hydrogen atoms. That means I find the same amount of carbon as I find of hydrogen atoms. That means the ratio is 1 to 1, and that means that the empirical formula is CH.